Greetings. Welcome to our 32nd episode of the FGI podcast series. My name is Tim Stark, and I'm a professor of civil engineering at the University of Illinois at Urbana-Champaign. On today's episode, we are going to focus on our July 22nd, 2021 webinar titled Panel Discussion QA/QC for Fabricated Geosynthetics. I'd like to quickly reintroduce our panelists. Our first panelist is Brian Queen. Brian is a lead environmental specialist with the Ohio EPA and a member of the George, or Geotechnical Resource Group, at the Ohio EPA. The George Group has created the leading guidance document on geotechnical and stability analyses for Ohio containment facilities, and it's being used elsewhere around the country. So Brian, thanks so much for joining us today. Our next panelist is Shannon Goodrich, president of Go2 CQA, which provides third-party CQA inspection services. Shannon has 32 years of geosynthetics construction CQA experience. So Shannon, thanks for joining us today as well. And our next panelist is Tanya Switalski. Tanya is the general manager of Titan Environmental Containment Limited in Houston, Texas. Titan is a major factory fabricator of geomembranes and geosynthetics in North America. So Tanya, thanks for joining us. And our final panelist is Ryan Camp. Ryan is president of Chesapeake Containment Systems, Inc., which is a large geosynthetics installation company headquartered in Statesville, North Carolina. Ryan's spent 23 years in the geosynthetics industry, starting as a laborer all the way up to starting his own company, Chesapeake Containment, in 2007. So panelists, thanks so much for joining us again and answering questions, additional questions that we didn't get to during the webinar and questions that we received after the webinar on CQA. So the first four questions are for Shannon Goodrich. Shannon, the first question is, what is the panel's opinion on wrinkles on an HDPE liner of a tailings dam constructed in a tropical region? Shannon, I had you on mute. Sorry. Please
Oh, no worries. Thank you very much. Wrinkle management is always one of the most complicated things to manage during a geomembrane installation. We don't like wrinkles. They have to be specified in a size. The design engineer, if the wrinkle is 4 inches to 6 inches, maybe it needs to be cut out and repaired. Maybe you want to think about using a white material to reduce the wrinkles. Maybe you want to sequence your deployment so you're deploying the liner and letting it relax in the coolest part of the day and seaming it in the coolest part of the day, not when it's at its most relaxed and wrinkled state.
Thanks, Shannon. And Brian Queen's with the Ohio EPA, and Ohio EPA is looking at a regulation for wrinkles. So Brian, if you could just real quickly touch on this forthcoming regulation.
Yeah, actually, in January of this year, we instituted a 4-inch wrinkle maximum specification. And basically, when you're placing your drainage layer over the top of that wrinkle, it has to be maintained less than 4 inches, which usually can be done by just having laborers work on the wrinkles as the gravel material is being placed, either splitting the wrinkle in half so you form 2 smaller wrinkles, or working in front of the wrinkle so it stays small and you're encapsulating smaller wrinkles instead of pushing a wrinkle across the facility that keeps getting bigger and bigger.
Great. Okay, Shannon, next question. A landfill placed 60 mil HDPE geomembrane on the floor of a new cell that abutted a pre-subtitle D cell. A 40 mil LLDPE was placed on the side slope of the pre-subtitle D cell over the waste in place. The LLDPE was then welded to the HDPE geomembrane on the floor. Are there any additional measures that should be taken with connecting 2 different plastic geomembranes?
Yes, indeed. Luckily, in this situation, you had similar compatible materials. The HDPE and the LLDPE do weld up quite well, and you do get a good structural seam and seam integrity on those. Essentially, when you're doing a tie-in, I always like to design in, yes, you do your tie-in, and I always follow it up with a cap to reinforce that tie-in, because a lot of times you're welding new material to old material. The level of effort on that labor, cleaning the old material, is quite laborsome, but it has to be done. You will get a solid tie-in, a structural weld on that, but you should reinforce that always with a cap, and that would be an extruded cap, pretty much the entire length of that tie-in.
Great. Shannon, another question for you. When using butyl tape, are you recommending its use only at bolt holes or the entire area under the gasket/batten bar?
I like to see it underneath the entire mechanical batten bar attachment system. It's a good protection. I feel it's a better seal.
Great. Last one for you in this segment, Shannon. There is MQA and MQC and CQA and CQC. Is there any kind of in-service QA, QC once the facility starts operating?
Yeah, that's a good question. It really depends on what sector the containment is. Landfills, not so much, besides the daily, weekly, monthly monitoring that has to be done by the landfill operations for any potential leak. On the water side, it's good to come back on a yearly basis and do a visual inspection, maybe probe some patches to make sure that the material is still adequately bonded. I do like to see either an annual or a biannual inspection, and usually it's by the quality control firm, or I mean the quality assurance firm that did the original CQA on the installation.
Okay. Two questions for Ryan Camp. First is, are there any limitations or precautions for PVC geomembrane welding and air channel testing in hot weather when PVC geomembrane temperatures exceed 50 degrees Celsius? Should we do welding and testing during night or when temperature drops to about 35 degrees Celsius?
On the welding portion, you always have to do your field trial seams, and historically speaking, the maximum temperature for seaming is controlled by the specifications. However, on the dual track air channel testing, here in the United States, we follow ASTM 7177, and that has a upper sheet temperature limitation of 43.5 degrees Celsius. They don't go beyond that. So for welding purposes, obviously your field trial seam and your specifications is what you need to use to control that. And then for testing, like I said, in the US, ASTM 7177 has an upper range of 43.5 degrees, and that's sheet temperature. So if you're following that standard, that's the hottest sheet temperature you could do while doing a dual track air channel.
Right. And so if they're at more than 50, they have to wait for a night or the temperature to cool down to get under the requirement in 7177.
Correct.
Yep. Okay, Ryan, one more. Are there any limitations for minimum and maximum length of weld line to be tested using air channel testing?
Start with on the minimum side. Once again, that can be controlled by specification. Sometimes they'll specify minimum seam length before it has to be considered a repair and extrusion welded. We obviously try to, minimize extrusion welding because it's an inferior weld to fusion welding. So once you get really below 10 feet and you have to cut either side to seal off your air channel, and then you're putting a 2 foot by 2 foot patch on either side, anything below 10 feet, you're really starting to get diminishing returns. On the length side, the long length side, it's really controlled by your panel lengths and your configuration of your area that you're lining. Typically we don't see anything beyond 750 feet, and that's really controlled by roll size. and we've been able to successfully air channel as long as 750. Typically, we don't go beyond that because of roll size or geometry of the site you're working on.
Great, thanks, Ryan. Last question from the during webinar questions, and this is for Tanya. Regarding MQC testing for PVC geomembranes, what is the most valuable and least valuable test specified by ASTM D7176?
I think that pretty much pertains to a project itself. Some of the more valuable ones would be tensile properties, the strength at break, elongation, tear strength, even the thickness is pretty important. But again, that kind of ties back to the project itself and what's important for that project and what they're going to be testing for.
Right. Okay, that's all the questions we didn't get to answer during the webinar. So now I'd like to turn to the questions we received after the panel discussion. So the first one is for Ryan Camp. If we use non-conductive HDPE, what is the distance and voltage to be used in leak location testing? And if we use conductive HDPE, what is the distance and voltage to be used in spark testing?
So in our experience, when you're a non-conductive geomembrane, we're either doing a localized spark test in an area where you might have where you can't get a vacuum box or an air lance, so a boot or a penetration, and you're actually putting a conductive media, under the patch inside the weld. In those instances, we're using a handheld spark tester, which is 110 volt, and you're really just limited to your length of cord. If you're doing an actual arc test with a wider brush on a non-conductive geomembrane, doing a full sheet arc test, those have a power pack. So really, you have to ground outside the lined area. So your only limitation is your length of ground, because your power pack is basically on the person that's conducting the test. And we typically see those handheld units go up to 35,000 volts on the high side. On a conductive geomembrane, it's kind of the same thing. The arc tester with the wide brush is it has a power pack, same thing, up to 35,000 volts. The only difference is you can use basically a drag behind sheet, that to ground out rather than grounding outside the cell. So you have a fair amount more mobility with that, not having to use a ground cable.
Great, Ryan, thanks. Next question from after the webinar is for Brian Queen. From the regulatory standpoint, are there any requirements in Ohio or other states during the post-construction period, i.e. active life period, for checking the integrity of the liner seams or penetrations, especially for critical structures such as floating covers, dam applications, etc.?
So in Ohio, really the only facilities that have post-construction active life leakage testing, so to speak, would be the hazardous waste facilities. And those facilities have a leak detection layer underneath the primary liner and above the secondary liner. So at those facilities, and to be honest, including leachate ponds for landfills, there is a active or a leakage action rate. And right now in Ohio, the recommended leakage action rate for a landfill is about 20 gallons per acre per day, and for a leachate lagoon is 500 gallons per acre per day. But besides the facilities that have a leak detection zone, there really is not a post-construction period active life regulatory requirement for those facilities.
Okay. We have another CQA question for Shannon. What is the most important thing a CQA inspector should do?
Well, for our group, it is understanding the technical plans and specifications, understanding the limitations of the material, understanding the limitations of the welding equipment, have all your forms ready, be hands-on with the installer. You work together collectively with the installer. If there are problems, you find solutions. And again, to do that, you need to have the field experience, you have to have the tangible experience, and you're literally interpreting the plans and specifications. So you need to be well versed in the geosynthetic business. And again, you have to work collectively with the installer and the design engineer at all times.
Great, thanks. Okay, next, another regulatory question for Brian Queen. How frequently do you believe a regulatory inspector should inspect when the geomembrane is being installed in the field? Has factory fabrication of larger panels helped, such as faster review time, getting CQA reports approved?
Okay, so during the liner, the geomembrane construction, we recommend our inspectors get out there at least once a week. And that's pretty much what we expect if there's a quality assurance. If there's a good quality assurance firm on hand and good QC firm on hand. If our inspectors get out there and they find things going on that we don't like and that we don't expect to see, then we'll definitely get out there more than once a week, every other day kind of standpoint. At our factory fabricated sites with the substantially larger panels, it's definitely reduced the number of destructs in the field. Depending on our facilities, some of our manufacturers aren't doing 100% seam testing in the factories. So those facilities have to do the 100% seam testing, but we aren't requiring the destructs on such a frequent basis. So it has reduced the number of patches that need to be made due to destructs. As far as review time goes, to be honest, there's not a huge difference in time. You know, maybe you're looking at 30 tests instead of 300 tests. But that being said, that's 5 more minutes of review time. So it doesn't really cut our review time down, but it definitely cuts the amount of work needing to be done in the field by the technicians themselves.
Right. Okay, another question for Ryan Camp. To what temperature can I test tack welds?
Typically, I really haven't seen, a standard that tests patch. Well, I'm assuming tack weld, they mean patches or repairs, which there can be multiple types. So if you're doing an extrusion weld, we typically recommend, you don't put a soapy solution and water on there until it's hardened. If you're doing it like a hot air weld, basically once it's cool to the touch, which happens pretty quickly. And then if you're doing a chemical weld with a PVC or a different type of material, I have seen where they don't recommend testing for 24 hours until it cures. But yeah, for the majority, it's until it's basically cool to the touch.
Okay. Our last question is for Tanya. Tanya, can you describe the factory CQC and CQA processes as you're welding in the factory and folding it before shipment?
Sure, I'll start with the CQA. CQA, we're actually going to be looking at the material itself, verifying that it's the specs from the manufacturer are meeting the project specs. We're going to be looking at the material, making sure that there's no defects in the material and things like that. CQA is going to refer more to the actual testing of the material. We actually will do destructs sometimes on projects, depending on the projects if it calls for it. But normal testing would be non-destructive. and would be tested out on a tensiometer, making sure that the parameters of the material are met.
Okay, great. I want to thank Brian, Shannon, Tanya, and Ryan for joining us again. And that's all the time we have today. If you have additional questions or would like additional information, all the panelists' contact information is in the slides that are on the FGI website. And it's the slide that's after their presentations. If you can't find that, please send your questions to the FGI at fabricatedgeomembrane@gmail.com, and we will forward your questions to the panelists. So again, Shannon, Brian, Tanya, and Ryan, thanks for joining us, and thanks for an excellent panel discussion.